Okay, this lecture is about the MIME protocol, which is one of the protocols that is used for email. That's why it was originally created. It can be used for other things as well. But MIME stands for Multipurpose Internet Mail Extensions. And the purpose of MIME was to give you a way to take things that couldn't be sent in email because they had special characters or were binary in nature. For example, maybe it was an image, maybe it was a movie, maybe it was an executable program, things that are not going to arrive intact at their destination. So MIME was first described in RFC 822, which was created back in 1982. MIME makes use of what they call types and subtypes to identify objects. So the types, the first part of this, would be things like text. This is some type of text in ASCII. It is an image. It's an audio file. It's a video file. It's a model, which would be for like modeling software, like AutoCAD, or for 3D printing these days, that type of thing. And then the last one is it is related to an application. So those are the major types that we have in MIME. We'll go real quickly through some examples of each of these. So as far as text goes, we have text/plain, which is just going to be ASCII text. So like the content of an email that is actually typed out in English in ASCII characters. Another type is text/enriched. So this would be something maybe not as popular as it used to be now that we have PDF and things like that. But there used to be RTF, rich text format, that allowed you to have different fonts, put images in it, that type of thing. One that we talked about when we were talking about web stuff was text/HTML. So this document is ASCII text, but that ASCII text is an HTML document or HTML code. Also related to the web, we have text/CSS. So CSS, if you're not familiar with that, is cascading style sheets, and that allows you to do advanced formatting on web pages. The next type was the image type. For subtypes, we have image/JPEG, so that's a JPEG image. We have image/GIF, so that's a GIF image. Not used as much as it was maybe during the 90s, but TIFF is a image format file that preserves the quality of the image. So TIFF files are very large compared to JPEG, GIF, or PNG files. Some of these subtypes start with VND. That means it's vendor specific. So we have a vendor.dwg, and that's an AutoCAD drawing file. We have vnd.dxf, which is also an AutoCAD file. And then vnd.svf, which is, I believe, an AutoCAD vector file. So those are some of the images types that we have. As far as audio, we have audio/basic, which is just an encoded audio file. We have audio/MPEG, which is an MPEG audio file. Under video, we have video/MPEG, so that's like an MPEG-4 movie. DV is digital video. /QuickTime is Apple's QuickTime format. Used to be super popular. My opinion is it's kind of going down in popularity these days. As far as model subtypes, we have Mesh for describing a three-dimensional object. We have VRML, which is a virtual reality modeling language. We have another modeling language called IGES, which I'm not familiar with. And then under applications, we have application octet stream, which just basically means these are a set of bytes that represent an application. We might have PostScript. Before PDF was created and popular, things were often printed to PostScript files or represented in PostScript files. We have Apple file. Back before Apple was a Unix operating system, files had a kind of content portion and a resource fork portion, and this was just a way to represent an Apple file so it could be sent in email. MS Word for Microsoft Word. PDF for PDF files. The next one's another vendor one, FrameMaker. I'd actually forgot about FrameMaker, but we used to have FrameMaker on all of our Next machines, and it was very popular. It's a somewhat complicated page layout piece of software. Continuing on, we have another vendor one for Lotus 123. This was one of the first spreadsheet programs that were out there. We have Lotus Notes for notes and email. Microsoft Excel, Microsoft PowerPoint, Microsoft Project, and then finally the last one is /zip. So it is a file whose contents have been zipped. So those are the subtypes. I wanted to give you an example of a MIME encoded email. I went back and looked through my old email. The first MIME email message that I seem to have gotten was in 1993. It was actually talking about MIME and MIME documents, which is kind of funny. But most of the ones I had were too long to serve as a good example. So I finally found an email from 1998. Maybe a tad long, but long enough I could, or short enough that I could put it on a couple of slides. So here's what it looks like. And I have sections, and we have that ... next part and some hexadecimal numbers. So that's kind of a division point. So notice for that first section there, it says text/plain. And it's a faculty member asking me about access to a high-performance Unix workstation. So this has the first part, which is text plain. And if I go to the rest of this email, notice that we have another division point that says this is an octet string. In particular, it is the faculty member's vCard. So that is encoded, and then I have down at the bottom that line that starts with .. is the dividing point for that section, and just happens to be the end of the email. So kind of breaking this down into more generic things, we have this. So we have headers. The header is going to tell us that it's MIME and what version it is. It's going to tell us that the content type for the entire message is mixed, and then it's going to give me delimiter text. Then that delimiter text is going to appear, and I'm going to have a chunk of MIME encoded information, which is going to have headers and a body. I will have that delimiter text again, and the second part of the body will have headers and body. Then I have that delimiter text, more headers, more bodies. So that continues on for however many sections you have. And then finally, you're going to have delimiter text at the end and might have an epilogue or an ending. So that is how a MIME message is structured. Another thing that we often have with MIME encoded email is encoding methods. And Base64 is one of the ones I want to talk to. It's very popular. And what it does is it takes our message and it splits it into sets of 6 bits. And then it represents each group within or the value for those 6 bits with a single printable ASCII character. And the next slide is going to show the encoding table. I like the one that's on Wikipedia. So this is what the encoding table looks like. So you take 6 bits, you look up the binary value, and then you put the character in the third column that represents those 6 bits. And then, of course, you reverse the process when you go to decode the message. So I came up with a little example here. And let's say we have these 4 bytes that we want to encode. And I show their hexadecimal value. The reason I showed it to you in hex, it's a little easier to break out into its binary component. So we convert each of those 4 bytes to their corresponding 8 bits, which is what I've shown here. We then take this bit stream and go through and group them in sets of 6. And we'll come back and talk about it, but notice over to the right we have that 0, 1, which does not have enough bits to encode it. So we'll talk about that in a moment. So what happens is once we encode that, this is how it's going to look. So the first set we had will encode to the first sets, capital Z, lowercase a, lowercase p, capital V, lowercase g. And then what happens is we have that 0, 1 by itself. So what we're going to do is we're going to add 4 zeros after that, and then we'll get a capital Q. So that's where the Q comes from. And the other thing is, why are there 2 equal signs on the end? Well, that is because in Base64 encoding, the process takes 3 bytes and encodes it into 4 ASCII characters. So, you know, the ZAPV is the first set of 4 characters. Then we have the G and the Q, and we don't have enough to have 4 ASCII characters. So for any missing characters, it's going to put an equal sign. So that's where we get the equal onto the end of that encoding string. So that's the Base64 encoding process. As far as Base64 advantages and disadvantages, of course, the big advantage is the whole purpose behind MIME, which is to take something that normally could not be sent in an email and encode it in such a way that it can easily be sent in an email. So that's the advantage. The disadvantage, because we're taking 6 sets of bytes and encoding them into characters which are 8 bytes in length, the resulting data that we encode is going to be about 33% larger than the original data, but the advantage greatly outweighs the disadvantage, and Base64 is very popular these days, both in email and other applications. So that's the discussion of MIME as it relates to email.